So in this section, we're going to introduce paper presentations, and to remind everyone, these are position papers on works in progress as well on prosperity and peace, or SDGs linked to prosperity and peace. So our first panelist is Yoni Nachmany. And Yoni?
Good afternoon. I'll be talking about mitigating geographic bias of image classifiers. In the last couple of years, researchers have highlighted the lack of geodiversity in open image datasets and the resulting bias of models trained on those datasets. Here's a photo from some Google researchers that tried to geolocate images from the open images dataset and found that the data is highly skewed to the US and the UK and Europe, which means that these datasets are limited in their capacity to understand representations of concepts that vary across the world and that are different than the Western version. I'm Yoni Nachmany. I worked with Aditya and Nikhil, who are in the audience, and we did this work at the University of Pennsylvania with Chris Kalsenberch. So what's the problem that we're working with? Here are four sets of Google employees and their wedding photos. And the first three, they're classified with tags like ceremony, wedding, bride, and groom. And those look like more traditionally Western weddings with a nice white, bride dress, and that's classified correctly with models trained on the open images dataset. But the last couple is just classified as person or people. And this is a photo of a Nigerian traditional wedding. So this is a problem if you're trying to work in parts of the developing world where your data doesn't just look like the Western version of a concept, especially around people. And we want to be able to detect types of people and important life events and cultural events in other parts of the world. And again, the problem arises from the fact that the data from common data sets, in particular ImageNet, more than half of it comes from the US and the UK. And a very small percentage is coming from places like India and China that have a very large proportion of the world's population. And again, if you've seen an Indian wedding or a Nigerian wedding in your open data set, how are you going to understand and predict that in the future? So our approach was using a data set called the Massively Multilingual Image Dataset. And I'll just explain how it was derived and how we used it a bit. So on the left, you see this image with the Indonesian word for cat. And this data set was proposed to translate words using the words images. So if, for the Indonesian word for cat, the English photos for cat look the most similar, then that's the translation that the system proposed. And other images of animals or Persian or pet look less similar than the word cat. So this is, initially it was proposed as a method to translate different languages. But what we get from this experiment is a set of up to 10,000 words and up to 100 images for words in 98 languages. And that includes more than 10 languages spoken in India. So the initial focus of our project was looking at English, or photos queried in English and photos queried in languages spoken in India, and exploring geographic bias on models trained on those different sets of data. So here are just some examples for the classes that we focused on. Again, focused on people that we thought were more likely to vary across different cultures, and that failures to detect people are more problematic. So if you've never seen cricket in your data set, or an ecosystem, farmers that work in a different climate, then your models are less likely to be able to understand those representations. And some other interesting attributes of the data set are that for Indian languages, the photos of police and military are kind of subtly different. So it's not just about mitigating bias, it's about getting a classifier that works really well for different cultures by knowing some of these subtle differences. And the last photo, this is the prototypical example of weddings. And again, our setup was, if we wanted to predict on images both from English and other languages spoken in India, how would a model trained only on English photos do? And then how would a model trained on a combined data set do on the test set of both images? And we found with ResNet 50, The English data set got around 74% accuracy, and the combined data set got around a 91% accuracy. So that's a really significant difference in the type of performance you can get. And just a little bit more on the process. Like with ImageNet, we had our 6 classes, but we wanted to expand how many images we could work with by finding synonyms and similar semantic words using glove embeddings. It's a tool from NLP. And we also had to deal with a lot of noise or photos that we didn't want to work with. So there are examples of cartoons or images with text in them, or photos that just aren't related to the tags. So we had to do a lot of cleaning manually in this work, and in the future you could imagine crowdsourcing some of this cleaning and even sending it to people who are located in the regions that we care about to get a more accurate set of clean images. And just highlighting some interesting results. With the combined training set, again, we found confusion between soldier and police, which kind of highlights the point that I was saying, that these are just a harder example to tease apart. Kind of more interesting to me is if you only trained on the English training set, then these 2 photos of weddings in languages spoken in India were predicted as children, and we think that's because the images that we had of children in English had very bright clothing, and those were the most similar to the type of attire worn in Indian weddings compared to weddings just searched in English. So the larger challenge that we're working on is addressing now what's become more of a known issue in the computer vision community, where if the data is only coming from the US and Europe, you're not going to be able to detect things that vary greatly in different cultures. And especially when it comes to people, types of people, if you've never seen a representation of a type of person or a profession or a cultural ceremony, then you're gonna fail, and it'll be problematic, and it won't work for the functionality that we care about. If you're trying to create a new application, you want to be working from a starting point of more diverse data. And this has become a bigger conversation of research in some big tech companies. So this is some work out of Facebook this summer, where they used a data set of different household objects distributed across different income groups, and they talked about how out-of-the-box classifiers from different companies perform worse on images from lower income groups. And they use an open data set to solve that, but their future work is based on using a lot of Facebook's internal data, images tagged with hashtags in different languages to try to mitigate this problem. But what we're proposing with the MMID dataset, which is hosted on Amazon Web Services as a public dataset, and it's available to anyone here, is the opportunity to use open data to better understand and explore this problem, and potentially address it by curating a future open data set, or even trying to understand what are classes that are most likely to be misclassified based on embeddings or representations of these images. So if you're interested at all, I would love to hear your questions and talk afterwards. So the question was how many images in our data set. So our target was around 100 images per category, and recognize that that's not that much, but in recommendations for fine-tuning pre-trained models, usually 100 is a good starting point, so that's where we aimed.
Train your models with regular ImageNet and then fine-tune, you said ResNet performed much better, is that just like you train 2 models with ImageNet, fine-tune one with your...
Yeah, both were started from ImageNet pre-trained weights, which is a good recommendation, and then we fine-tuned both models just on the English data and then a combined data set.
There are, depending on certain things you're trying to distinguish, where is the field at?
That's a great question, and I'm also now more in the remote sensing world, so I appreciate that there is more standardization. And so here, not so much. There's people are trying to develop standards about how to bring in uncertainty or probabilities from classifiers and carrying that along with predictions, so that people have more information, more awareness of how confident maybe a model is, but it's not kind of as scientific as remote sensing. And yeah, it's in general, people just hear recommendations. You just use ImageNet pre-trained models. They know features of many images, and that's just a good starting point. And people might use models only trained on that data because it has many categories, or they might fine-tune these models. But pretty much people just run and go with that data, and it's people aren't as conscious as I wish they were. Thank you.
So next up is Larissa Siddartha and Magisha.
All right, hi, I'm Larissa Siddartha. I'm the Director of Business Development at Hara, an agri-tech startup from Indonesia. And this is Magisha, our business analyst. Today we'd like to share with you our Hara experience in using data to promote financial inclusion for smallholder farmers. So to start with, 13% of the Indonesian GDP comes from 38.7 million farmers. They make up 50% of the population that lives below $1 a day. So studies have shown that financial inclusion reduces poverty as it stabilizes income. For example, through credit, farmers are able to invest in working capital and thus maximize their capacity output. But the thing is, Indonesia, only 6% of farmers are credit beneficiaries. So then the question is why? Simply put, data is generally not recorded in the agriculture sector. So for formal financial institutions, it is very difficult for them to locate, identify, and find credit-worthy farmers. So simply put, it's way too expensive and too time-consuming for them to do so. And so what do the farmers do? They go to local money lenders, and they charge exorbitant high interest rate from around, we're talking about 120 to 240% per year, or even there were cases where it gets up to 3,600% a year. So high cost of funds means high production cost. And for farm hardware price in Southeast Asian countries, Indonesia is the highest by far. With this, it's not too shocking how it's a problem. And I would like my Magisha to share about the current solutions.
So to tackle the high agricultural costs, the Indonesian government has several initiatives in place, one of them being KUR. Kredit Usaha Rakyat is a national microloan program where state banks offer loans at around 7% interest rates to micro, small, and medium-sized enterprises. However, the Yusof Ishaf Institute conducted a study where they discovered only the upper levels of these enterprises actually benefit from the program. It is only businesses located at urban and more economically active areas that gain access to the credit. As a result, businesses that actually need it do not benefit from this program. So there has been a rise in private initiative to alleviate poverty in rural areas. It's through peer-to-peer lending. So anyone can now offer loans at a set interest rate to unbanked individuals. There has been a lack of fully integrated technology and scalable human analytics in the peer-to-peer industry, resulting in reduced transparency. Exploitative actors have begun to emerge on these platforms and take advantage of unbanked communities. So therefore, a lack of information on rural population and a lack of means to get this information reduces the efficacy of these two programs.
So this is actually where Hara comes into the picture. Our mission is simple. It's to make information available. And we do this to make the invisible become accessible. And how? Through data. Data is key. So we facilitate this process by grooming local community members, what we call Hara's field agents or agripreneurs. They essentially come to their neighbors, the farmers, and collect data. And the data is then used to open up opportunity for the farmers to apply for loans. This is Mbak Nun here. She's one of our 700 agripreneurs. She manages around 200 farmers in her village. And so she collects data and meets the farmers in the afternoon when her husband is at work and her kids are at school. So the simple notion is there are people willing to share the data for future potential benefit. And there are institutions who are willing to pay to access for the data. So our ecosystem works on a bottom-up approach. So we collect data through the agripreneurs and essentially creating jobs because of that. And now financial institutions are able to utilize the data and to expand their markets. And then we also have farmers who now gain the access to have the ability to choose for other formal financial goods or services. To date, I'm very proud to say that although it's within just over a year, we have achieved over 26,000 farmers into our ecosystem across 598 villages across Indonesia. And through our bank partners, we have disbursed $376,000 US dollar microfinancing to people previously deemed unbankable, and with a repayment rate of 97 to 98%. And because of our consistent pilot results, our bank partners have even now agreed to disburse 14.7 million US dollar for the next 7 years. And so we do this through our technology futures. One, record digitization, making it simple for our agripreneurs to input data and help apply for loans. Geotag, essentially standardizing land measurements to be able to calculate and monitor productive assets. It seems simple, but I've had answers when asked to farmers, what is your size of land? Answer is from one coconut tree to another coconut tree. And consent. This is very important. So to ensure data is not used inappropriately and tampered inappropriately, farmers, we implement one-time PIN system for the farmers. So farmers will get codes to put into our system, the code for us to put into the system to continue forward with changes to the data. And so this is just an example. This is just to show you what our application looked like. We put farmers' data, selfie with our national ID, geotag, help apply for the loan application. We combine machine learning and manual verification to streamline the process of checking whether the ID is similar to the face. And this is loan application. This is to show you the types of data used to support. We get pictures of farmer IDs, farmer spouse, their family certificate, their marriage certificate, their land image. This is how they do the land tagging. And we also built this on top of blockchain technology to ensure the whole transparency and traceability of the data.
Given the success of our microloan programs, we are also looking to expand into crop insurance and Hara Depot. Farmers need insurance to manage risk more effectively because, in essence, their livelihoods depend on this one plot of land. So we have a pilot program in place with Koala to ensure that these farmers have a financial safety net from unpredicted events such as droughts. And the Hara Depot is in essence almost like a working mechanism where farmers can use their credit to purchase productive items such as fertilizers, seeds, and tools at local farm input stores. So we are working in partnership to ensure that loans are used for productive purposes. And we already have we have like about 5 to 10 in place right now. It's currently in pilot as well.
Thank you. If you want to learn more hara.ag.
Thank you so much. So next up is Davis Adieno.
Thank you so much. My name is Davis Adieno, Director of Programs at the Global Partnership for Sustainable Development Data. Now, there's a caveat here. So if you have any technical questions, we'll have to correspond through email because I'm making this presentation on behalf of my GIS Technical Manager, Dr. Kenneth Mubea, who couldn't be with us here today. And it's about the Africa Regional Data Cube and how you may have heard our CEO early this morning mentioning how the government of Ghana, Kenya, Tanzania, Senegal, Sierra Leone actually using Earth observations data to track a number of different indicators on the SDGs. African cities, just like any other developing regions, are experiencing rapid urban growth. However, there's been a lack of data that can support city authorities and other planners to effectively manage this particular growth. The Africa Regional Data Cube, which is a partnership between the Global Partnership for Sustainable Development Data, NASA, the Committee on Earth Observations Satellite Data, the Group on Earth Observations, GEO, the governments of Kenya, Ghana, Senegal, Sierra Leone, and Tanzania. I'm highlighting a specific case here where the government of Ghana is using the Africa Regional Data Cube, which is an infrastructure basically that makes satellite data, analysis-ready satellite data available to these governments for use to track various issues ranging from urbanization, agriculture, coastal erosion, forestry, and others. But this specific case study is focusing on how Ghana Statistical Service and a number of other partners are using the ARDC to report on SDG 11.31 on urbanization. And this is something they included in their voluntary national review report that was presented at the high-level political forum in July. The extents of Kumasi lie between those geo-coordinates, and it's the capital city of the Ashanti region in Ghana. You'll see in the context of the whole country, there's a map that's showing the specific location. More importantly, the region has seen increased population from 346,000 in 1970 and about 2 million in 2010. So you can see that's a significant rise in the population. Obviously, there are a number of different reasons for this. Mostly, this is linked to economic activities such as industrialization, people coming to the cities to look for jobs. There's commercialization and, of course, economic growth. This is just a pictorial presentation of what the Africa Regional Data Cube is all about. We have 8,000 Landsat images covering over 17 years. And then we have 1,000 data cube storage units, which are processed and ready for analysis. And then this is compressed further, about 8 times for storage purposes. And we use then the Open Data Cube infrastructure that was developed by the Australians to make this data available and analysis ready. And you can run a number of algorithms using an online user interface. And of course, these tools then help governments to select geo-coordinates, the years of analysis, and run the algorithms which give them specific products depending on what sector they're looking at. These are just some of the algorithms that are available within the Africa Regional Data Cube, looking at cloud-free mosaics, the spectral indices, there's land classification, there's water. So you can use all these different preset algorithms to run analysis for different areas. Now, I'll zoom into the case study. The RDC was used to monitor SDG indicator 11.31, which is basically looking at the ratio of land consumption versus the population growth. And 11.31 provides a metric for determining whether or not land consumption is actually scaling responsibly with the growth of the population in a particular area or region. Using the Africa Regional Data Cube, this was the extent of urbanization in the year 2010. But by 2017, when the analysis was run, you could see that the concentration of red had really increased. And we compared these results with the results of trends.earth, which is an urban mapper. And clearly the results we were getting using the Africa Regional Data Cube and Landsat imagery was quite similar to what trends.earth would actually give you. And of course, the extent from the Ghana Data Cube is shown on the left, like I said. And you can compare that to what Trends and Earth Urban is giving us. The results were that 5.7%, the urban area growth was 5.7% per year using the analysis within the ARDC. The population growth was 5% per year. That's according to several online resources, and we're working very closely with the Ghana Statistical Service to provide the data that's actually needed to do that. So, according to the Ghana, obviously these are the formulas that I use to calculate the ratio between land consumption and population growth rate. So it was a combination of these two formulas, looking at population growth rate and then how land within Kumasi is actually being consumed relative to that population growth rate. Those are the formulas. I'll not go into details of that to save time. But this is the spot we're actually looking at within the map of Ghana. So that's the Kumasi metropolitan area, which is the capital of the Ashanti region. In terms of the results, well, these are some of the technical formulas that the GIS technical manager and other partners were using. But this is a very simple pictorial, representation of that particular growth. And you can see very easily that this is much more concentrated. If you were to compare the extent in 2000, and by the time looking at the second image, that's 2015. Obviously, there is a big difference in terms of the concentration of the population and the extent to which urbanization has happened. Now, the analysis was actually done using a simple fractional cover threshold approach to identify the urban regions, and those are the findings, like I said earlier. But the results actually indicate that the land-based urban expansion rate is higher than the population expansion rate. So, based on some of the ground truthing, we discovered that more people are moving out of the concentrated city and taking over more land. So the city is actually expanding outward. And then the methodology, 11.31 methodology, was developed by the National Administrative Department of Statistics in Colombia, which was actually practically applied. They actually shared this with us, and we worked to go together with the Ghana Statistical Service and the Ministry of Environment and others to try and apply it in Ghana. A lot of back and forth in terms of tweaking the algorithms to make sure that it gives us the results we were looking for was done through a government coordinating mechanism that we have set up in partnership. And it brings together private sector, it brings together members of the civil society, and other social enterprises that are interested in Earth observations data for sustainable development. Though these results are preliminary, the Africa Regional Data Cube obviously needs more data on non-urbanization to provide better analytical results. What are we trying to say? In as much as we are using Earth observations data, we need to basically do a lot more in terms of ground truthing to confirm that the results we are getting are actually pretty accurate. Thank you very much.
Thank you so much, Davis, and for highlighting particularly how this all relates to the SDGs. So next up is Justin Koufopoulos. Justin?
This project is called the AI Playbook. And I know what you're thinking, Playbook, that sounds really exciting and cool. in the government when we work on like technical projects, because there's not a lot of staff in agencies that understand these things, we try to compile lessons learned that different technical leadership can use later as reference material. So just some background history of the project. This was a project that was spun out of an innovation fund that we have in government. So we have almost like a little VC within this agency called the General Services Administration that funds projects with small amounts of money to sort of see if there's something of value that can be created. I am part of a program called the Presidential Innovation Fellows Program. So the Presidential Innovation Fellows Program was started in 2012, and I became a fellow in 2016. It was started by President Obama to bring in entrepreneurs, technologists, designers into the public sector to try to do good work. And we collaborated, and sort of the context that this playbook is coming in from a cultural standpoint, there's a lot of pressure on government agencies to begin experimenting with artificial intelligence. We've discovered open data, in maybe early 2008 or so, and with political pressure and sort of competition that's happening in industry, there's a desire to do more artificial intelligence. And other policies are coming out, but really, we don't really know, I think, many things in the federal government about how AI can be useful and also like what's the impact it's going to have on the federal workforce. So initially, the scope of this research was to address and assess, what likelihood would there be jobs displaced and under what timeline. Initially, during our research, we found out pretty quickly that there wasn't a ton of this happening yet. Just the state of the industry, it's pretty new in the way that government buys software. We buy things off the shelf, and so there just isn't that an issue that's happening right now. And I'm talking about machine learning now, kind of going forward. So we ended up actually changing the scope of our project to look at what were some of the barriers to actually bringing machine learning into the federal government, and try to see if we could actually work through some of those. And we talked to different agencies like the Department of Veterans Affairs that have massive problems with paperwork and things that actually perhaps could be automated in some way with machine learning or other kinds of technologies. We discovered some interesting things in this first phase of this research that's really meant to kind of just identify is there a problem here, which is just that there is a perception of machine learning which doesn't really match the reality, AI specifically. There is a lot of fear and concern within government about machine learning and artificial intelligence really replacing people's jobs. But we also don't really know how the government is using AI holistically. I mean, the government is huge. There are millions of people that work there, lots of projects. So for the second phase of this work, we wanted to understand, what is actually happening in the government and what are some of the factors that lead to successful use of machine learning. And so what we learned, and we did a number of different workshops with data scientists, CIOs, chief information officers, chief technology officers, data officers, and we learned some interesting things. So one, very few agencies are actually using machine learning. Where we see actually machine learning happening is in the scientific agencies, specifically NSF, National Science Foundation, NIH, but we're not really seeing it in the workflow of people on a day-to-day basis. And like I was saying, it's mostly in cases where there's deep technical expertise and a deep problem understanding as well. And so when you don't have those two things together, it's really difficult to actually apply machine learning. And I'll say that probably a lot of these things are going to sound familiar to you all, but we're sort of at this cultural transition in the government, and we're trying to actually, make these lessons available to more senior leadership who are trying to think about these things from a higher perspective. The third thing that we learned was just that there's very few successes with off-the-shelf solutions. So I think that gets into some of the things that we're talking about today. You really need people in-house that are able to, train models and understand data. And buying something off the shelf, we just haven't seen many successes with that so far. And then I think four, and maybe most importantly, is that culture actually beats technology. So in cases where we did see machine learning happening in the government in a way that was exciting and actually solving problems, we just saw leadership that really cared about innovation and cared about taking care of people. And whether it's machine learning or something else, they're doing experiments constantly. So it's not like the goal is machine learning, the goal is innovation. And so I think this is actually a lesson that's useful to anyone that's out in a large bureaucratic organization where there's not a lot of technical folks in-house. and then another thing, and I'm not sure, if this is something that other folks in this room have familiarity with, but procurement is the way that government buys technology, and these procurement cycles are really long. So you might have sort of a request for a proposal, and it could take years before actually something is delivered. And so that's where really you start to have issues with actually delivering things that are useful for people. And so in terms of next steps, we've created a playbook, and it's out in the open. We've published it on GitHub. It's at GitHub/Presidential Innovation Fellows /AI Playbook. And we're trying to bring those lessons together so that other agency leaders can actually start to understand some of these deeper issues and get folks from the community, data scientists, technologists, engineers, designers to look at this and start to hammer at it a little bit, because we want to be providing information that's valuable and useful to folks within government agencies that are coming to these problems for the first time. In terms of recommendations that we have for other organizations, government agencies, but also local government, nonprofits, I think bringing in, first, understanding your problem. We see a lot of cases where the technology comes first rather than what the problem actually is. Two, bringing just experienced professionals in-house. So rather than relying on folks that are maybe removed from the data, removed from the problem, bringing them into the organization and getting access to those teams is really important. Run many different experiments. We find that actually it's non-obvious when machine learning or AI is actually a good solution to a problem. Many cases like automation, software, a new service is actually better. So the other thing I think that leads into that is just be wary of off-the-shelf solutions as the answer to your problem. Some folks within this session even talked about that a little bit in terms of biased data. And then finally, just build data-driven innovative cultures. I mean, this is, for sure buzzwords, but I think it means, having folks that actually are trying to solve the problem in any way and be willing to look at the market for new ideas and read research papers. We saw, statistical agencies that are actually trying to, really be on top of the academic research and then work with their managers to apply those lessons in-house. And so, yeah, I will just say that, I think if you really want to have a major impact in this field, come to the government and help us buy the software better, be able to work with the folks that are trying to buy it and help them ask the right questions, because these services, if you're talking about ethics or bias, they can impact millions of people. And so, yeah, again, the GitHub link is here, github.com/Presidential Innovation Fellows /AI Playbook. I'm Justin. And I'm part of the Presidential Innovation Fellows Program. Thank you very much. So I did get through everything. That's kind of amazing. Yeah, any questions?
It's a question that's occurred to me in each of the presentations in this session, but it really came to life in yours. That you've done some fabulous work that's really of interest to lots of agencies, not just within government, but in private sector and not-for-profit as well. What more can we do to make sure that once you've learned something like this, it really does get adopted across the whole community?
Yeah, I think that's a great question. I think, a few things come to mind. One, I think, is documenting these lessons and trying to put them out there. And what we're trying to do with this playbook, putting it up on GitHub and engaging the community to have these conversations is, I think, one part of it, because oftentimes these problems get solved in a silo, and then no one talks about it, especially in our world. I think other things would be, just being able to try to engage new people in these conversations. I mean, this room is mostly it seems like technical folks, but I think we do need more people from the federal government here, nonprofits, folks that are actually not even technical, but are people that are just trying to closer to the problem, are trying to solve the problem, but maybe don't have that kind of expertise. I think that's another really important thing that we do. Yeah.